Howdy, AP PreCal. It's Miss Kosh. We are continuing with what I am going to cover with 3.7. So we started with this one problem that may or may not be 3.7. It might be 3.1, but that's the free response number 3. So I had a video for that. And then we used the part from the modeling of equations, or excuse me, the modeling of sine functions by hand. So this was the page, I think I had a video or two of this where we were modeling it by hand. And then we did this harmonic motion problem by hand, and now we're jumping into using the calculator. And so I grabbed my calculator and typed in this table with the CASIO. I went under statistics. We have done a number of regressions already. So if you're new to me, go find some other of my videos that make you a little more familiar with the CASIO, or figure out how to do it on the TI, because it'll work there too. Okay, so when I'm in here in statistics, I have all my data in, and I go to graph. It might help to set it up. So if you're not getting what you want to go here. I want a scatter plot. I want the X to be list 1. I want the Y to be list 2. If for whatever reason I want to change that, I could, but everything's great. So now we just can hit over here, hit graph, and it will find those points. And they sure do look to me like a sine curve. So I can calculate a regression. The one that I want go over is sine right here. So it will, the way the CASIO does it, you only can do a sine regression, not a cosine regression. Now you could take this information and tweak it. One nice thing it also does is that I can copy, and when I take it here, I had some other stuff, but if I hit copy, it'll take me to kind of the graph screen. I want to hit execute, so you can see. I want to hit the enter or execute button, so then it'll take me back, and now what it's done is it copied that into there. So if I hit draw, it's going to kind of model those points for me. And then I can manipulate this equation or work with it or do other things with it inside the graph world. So if I hit menu and I come back to graph, I don't remember what this equation is. I don't know. Okay, but I'm going to delete it. I don't need it. This one is not currently on. I have to select it. So it puts it in where I was highlighted before, like into that Y1. So if I wanted to have multiple equations, I could come down to Y2 and then hit enter. But I need to turn it on, and now it should still be in that window that it created a minute ago, which is going to be convenient. Notice if I come to window, shift window, this is not a typical. We're going from 55 to 83-ish for our Y values. That's not a typical window, but it set that window based on the points that it saw that we plotted, which is great. Okay, so here's our curve. If I want to, it says, oh, okay, use a sinusoidal regression to find a model for the data. Well, we did. The way that the CASIO typically writes the equation is they'll say y is equal to a sine of bx. Do they say plus or minus c? I don't remember. We'll check. Plus d. But whether this is a plus or minus, the point that I'm trying to make is that they don't factor out the b. So sometimes what I would do with in my IB class in particular is we'd have a plot of these points, and I would say, okay, you guys write the equation. See if you can write an equation from this information by hand. Manipulate this, and then what they would do is they would take the one that the calculator created and then put the equation that they came up with in the next one. But when we start creating equations, we tend to say something like y equals a times sine of, well, they may have used cosine too. They might have looked at that and thought, well, okay, let's see, hang on, let me come back to that and show you what I'm talking about. If I hit exit, go back to our menu, come back to statistics, I want to graph that. When I look at this, okay, I would probably use a sine equation, but I would probably make it a negative. Since it seems to be starting here at 0 and then it goes down first, I would make my a negative value. And then, but let's see, what did our regression give us? We calculated this regression. I don't need to copy it again because it's already there. The a value was positive, so it does have some sort of a shift left or right with c. Notice their c is it's a plus c. Okay, so I wrote that wrong, but it doesn't really matter. If we had written it by hand, I would have written it where the b value was here, and I would have factored out the b value and said b. Well, okay, I'm used to writing minus c, so you can see that it's a shift, but you can make that a plus. I would write it this way, and so when we're comparing our equation that we wrote by hand to what the calculator gives us, the c values are not going to match. So be aware of that. They forgot to, well, they very intentionally, I guess, didn't factor out the b. So it says use the sinusoidal regression to find a model for the data. Let's practice. Let's get 4 decimal places just because AP wants us to have 3, and if we do 4, we'll definitely be right with a third. Does that make sense? Okay. And let's use the variables they gave us. Okay, so f of t is equal to our a value, 7.9468 sine of b, oh goodness gracious, 0.2796 x plus our c value, plus a negative, minus 2.9370, close parentheses, and then plus d. My d value was 69.9343. Oh, goodness gracious. Okay, well, that'll be fun to grade. Anyway, maybe I'll have you use this. Okay, so now it says use the regression model to predict the temperature at 2 p.m., which is at time when t equals 12, because what they were telling us, it's time after midnight. So 2 p.m. is 14 hours after midnight. So what I would do is I would then come back to my graph. Here's my equation. What I want to know is when x equals, I can do gsolve, hang on, second, I didn't hit gsolve. Here's gsolve, go over to ycalc. I want to know when the x value or the t value is 14, what's our y value, and so it's 76.5215. Okay, let's just say 77 degrees. I don't know. I mean, okay, 76 point whatever. I mean, that sounds like a lovely temperature to me. I live in Texas, so we don't get 77 too often. We're either too hot or too cold. Okay, one more, looking at this one. 2 children are going, I haven't thought about this one yet, so if I have to come back to the next video, my apologies, but you'll be fine. Okay, 2 children are going up and down on a seesaw. For child B, the end of the seesaw is 3 feet off the ground when child A's seat is a half a foot off the ground. Okay, so the height of seat B is modeled by that, where t is time in seconds, and t equals 0 is the time when the seats are first at the same height. Oh, okay, so they're first at the same height, somewhere here, and then they're going, it's a positive, so it's going up, and it's going to come back. So basically, they were, his maximum height, is that right? Let's see, 1.5, yes, his maximum height is going to be, this is a y value of 3. Our minimum height is 1/2. I was too lazy to write a decimal point. And so we're doing something like this. Okay. If the children seesaw for 8 minutes, oh my goodness, okay. So how many times will child B be at the maximum height? Well, his period here is, this is 2 pi over B. They did say to use a calculator, and I'm not currently using a calculator, so 2 pi divided by pi over 5 is the same thing as 2 pi times 5 over pi. Oh, that's not over pi. Let's try that again. The pi's cancel. This gives me 10. Okay, so in 10 seconds, he's been up once. So if we're looking at 480 seconds, that's going to be 48 periods. So he will be up at a maximum of 48 times. You know, not going to lie, that's a long time to seesaw. More power to him. Could my calculator have helped me on that one? Sure. Oh, by the way, I meant to say this earlier. I'm in radians. Everything works better with trig graphs if you're in radians. And luckily, AP requires you to stay in radians, and IB would go back and forth, but they would be in radians. Okay, so let's see. If I had typed this in, 1.25 sine of, let's make that a fraction, shift pi over 5 times, we don't have a t, but we have an x. We have a t if we switch it to parametric, which we don't want to do. Hopefully I get to teach that to you later. Okay, so there's my equation. I can probably change the window, shift window. My x values, we wanted to go for well, -4 is probably fine, but we wanted to go for 8 minutes, which is 480 seconds, so maybe I'll put in 500. Okay. And then how high did they go? He went as high as 3 is what they told us. So let's say, and as low as let's go from -1 to 5, just so we can see our graph. Well, that's ridiculous. So count the number of times it's at the top. Well, I don't recommend it. Okay, so let's change that window. Let's go from, we just said we had a period of, let me prove to you that the period is 10. Okay, so I can do G-solve and come to the max. So here was one at, the maximum is 3, which we knew, and that happened at 2.5, and then the next time it happens is at 12.5, so they're 10 units apart. So we have 480 seconds divided by a period of 10 gives us 48 times that it's at the very top. That was fun. All right, subscribe to my YouTube channel and go practice.